It's great to be here. I also would like to take a selfie, but I'm too shy to do it, so maybe next time. Anyway, as we all know, there are huge changes in industry and especially in energy sector, I would say. And the big change is about the production, how it has been changing over the years. Wind power used to be relatively small, local things. Nowadays, it is one of the most important energy things that we have. And the same is happening with solar. It is increasing really rapidly. And the same development continues. In a couple of years' time, in 10 or 20 years, the amount of wind and solar combined, it is expected to be about half of all the renewables globally. And in many countries, it will be 100%. And together with this development and accelerating it is the development of technology. You see how the prices of solar cells have been decreasing drastically. And the same is happening with batteries. And this is good. This is good news because both are needed. We have intermittent solar power and we have flexibility of batteries. And the batteries will be used more and more in cars. In both developments, what is interesting is that not only the price development, but the scalability of technologies. You can have a large solar system or you can have a small system. The economics of scale is not that huge as traditionally in power production. The same with the batteries. You can have small ones or you can have large ones. The economics is almost the same. So this has led into the distributed model we have nowadays. For example, this is an example of Germany where we have a few tens of power plants producing electricity for the whole country. And nowadays we have hundreds of thousands of energy producing units all over the country. So this is a huge change. You can imagine what it means for the distribution and transmission grids. And what is happening with cars? We all know about the electric cars. They already exist. Maybe not so usable to myself, but see what is happening in industry. See how much the car producers are really investing in this. And you know they have huge resources and they are able to make things happening. And this slide is about the cars that have already been announced. So there will be new cars with the 400-kilometer range within a couple of years' time, available about the prices that we are used to paying in traditional cars. So this may change more faster than we expect. Back to production. It's great that we have these renewable sources, but they have also some problems. It's not that easy to control. It's not easy to predict. The wind is changing. The sun, how much it is shining when we have clouds, it is changing all the time. These are examples of a cloudy day and a sunny day. On your left-hand side, you see that the variations can be really rapid. If you think about a system where you have a major amount of solar power, and you see how drastically it may change from 0 to 100% production, it may be a challenge. And the same with the wind. It is more year-round, night and day, but it is changing all the time. So we are used to a situation when the loads are varying, but the production is controllable. And now we are in a situation that the production is no longer controllable, not that easily. Another challenge is that the current system, what we have, is very rigid. It's really stiff system. You cannot really, you can do many things wrong and still the system is stable. It has lots of inertia, lots of rotating mass in big power plants. But when we go to wind power and we go to solar power, there's practically none. It is like comparing a bowling ball to ping ball. The other one is really easy to shake. So the system will be less stable than what we are used to. So this means that we have to have not only flexibility in loads, but we need to have a real-time flexibility of roles, rapid controllability of loads. And this is a big change that what we are experiencing. And this is why we are talking about energy storage, we are talking about demand response, smart homes, even smart cities, how electric cars can be used as a part of this energy system. This is a kind of a micro-scale example of these challenges and how they are being resolved. This is a new ABB product. It's a combined solar inverter and battery storage with some built-in controls that can control your loads according to the how much we are getting sun. If there's a cloud, it can disconnect some loads, for example, electric cars. So this way we are stabilizing locally and we are maximizing the use of electricity within the house. Another example is smart homes. We have lots of, I'm sure we will hear today more about these smart homes. But in homes you can have all kinds of automation, new types of loads, new types of production. And single home is not that much what you can change, what you can control. But when you have hundreds of houses, it really becomes an asset for the aggregator. This is one example that we have done together with city of Helsinki and Helen energy company. We have this pilot houses, pilot buildings in Kalasatama, where we have about 100 flats and about 50 electric car charging stations equipped with home automation. Each home has about 18 controllable loads. So basically each individual socket, lighting, everything is measured, controlled. Also the use of cold and hot water, it is being measured in real time. And on top of that, we have the connectivity for applications, for Helen applications. So we need to have a real-time gateway. It has history so that the people are able to see what has happened in their consumption, how it is developing. And on top of that, we have also a standard interface. And this is very important. Also for this sector to develop, we need standards, like in all over. In networks, in any communication, there needs to be standard for things to develop. And this is something that we have been developing based on IEC standards. We have this standard data model for demand response. And I'm hoping that everybody who is now considering about building demand response applications would be using this standard system so that we could get this standard kind of a worldwide accepted general standard for everyone. Anyway, many things are happening, but we are still in very early phases and lots of development needs to be done. There are lots of opportunities, and I would say that Finland is definitely one of the best places to develop these kind of things. We have a great demanding customers who really are ahead of time in Finland. We have a great universities that are ready and willing and able to cooperate with companies. And we have this great ICT cluster in Finland. So definitely I'm hoping that we would be able to do something great here together. Thank you.